Okay, you are welcome to today's lectures on PhD 253, Pharmaceutical Calculations. We'll continue from where we stopped in our last class, numbers and numerals. I can remember vividly that I define numbers and types of numbers, and I think I stopped at I just listed the numbers under real numbers. So I said that in our next class I was somehow distracted because of final year's mock examination. So I think we are through by God's grace. So now let's now go to PharmCalc and see what you can cover before your exam. I also had a breakdown of what you should expect in this course. I think I told you everything concerning your CA, your examination, the scores, the mark distribution for each of them, and how your CA will look like. And I say that immediately after, once I'm done with these numbers and numerals, on entering another topic, the next day I will enter. That day I will start another topic. I will create time for our CA. Our CA will start. Our CA will start. So once I come here, if I point at you, there's no particular order. If I point at you, you come here, collect your own question and solve. As you're solving, I'm scoring you. So, as anything you are doing, is not the time. This is not the era of after class you pack your notes or pack your material and go and keep and be gallivanting. It starts now. So let's take it seriously. I'm just saying it for the benefit of those that we are not in our first class. Good. I drew number line for us, and I told you what number line is all about, and I also said that real numbers are those numbers that can be placed in the number line, whether it is what is called again is one you can see and one you cannot see. And I told you that in between, that if this is the number line and here is 0, here is what? And here is what? Positive infinity. That from here to here, if you see numbers here, let's assume we have minus 1, minus 2, minus 3, and what? Minus 4. And we also have 1, 2, 3, 4 to infinity. I told you that between this minus 3, 4 and minus 3, there are what? Numbers here. Main numbers are here. Are we together? Main numbers are what? Here. Look at this root minus r, minus 1. So where will even place root minus 1? It has no, you cannot, it's imaginary. True of us. That's why they call this what? Imaginary number. And it's what? I. So no matter where there's no way, how will you even solve this? So they didn't know what else to call it. They call it what? I, and call it what? Imaginary what? Number. So that's why real numbers, you can easily place real numbers here. It can be this 3.144 should where? Where do you think 3.1444 should be? Where exactly? In between what? Good. But can you place it here? Can you see it now? But it exists here. That's why I told you that both the one that you can see and the one you cannot see can be a number line. Those ones are what? Real numbers. And I went down again to tell you different numbers under real number. The largest of them is what? Integer, right? Yes. Then after integer, you have the what? Natural numbers. Integer is from here to here. Are we together? Yes. Good. Then next one is what? natural from 0 to what? Positive infinity. Then you have your what? Whole number from 1, right?
Yes.
Good. Then you start having you start having your rational numbers. I told you that. Okay, now let me now pick them one after the other. I think I remember where we stopped now. I listed them and left. So now let's pick them one after the other. There's no, I have already mentioned, explain what they are. So, but let's just see what we can do. Now here, if you pick up four whole numbers, there's no long story there, right? Because just from what? 1. There's no long story there. Just know that whole numbers are numbers from positive numbers, or you can say whole numbers are positive integers from 1 to the what? Positive what? Infinity. Am I communicating? Whole numbers are from here 1, 2, 3. Those you can easily see on the what? Number line. 1, 2, 3, 4, 5. They are just the counting numbers. Numbers you use in counting. Counting numbers. Can you count to 1.0702? Can you count to 1.15? You cannot count, but you can measure it, 3 of us. So note that, mark the word counting. It's different from 1 point. Can you count? Okay, you can sometimes 1.5 is okay, 1.25 depending, but counting are just these whole numbers. Okay, hello? Natural numbers used in a normal daily counting, with the exception of what? 0. From 1 up is a what? Whole number. But natural number are just our normal counting numbers. From 0 to what? Up. Can we count -1? So from 0 to what? Positive what? Infinity. Now, the next one I want to look at, where I really want to explain, spend my time to explain it, because it can be confusing. It can be confused. Something like rational number, rational numbers, irrational numbers. We are continuous. These are areas I want to actually take my time to explain. And what? Discrete. Continuous, discrete. There are some rational numbers that are continuous. Okay, let me write them out. You can also have your what? Continuous what? Rational what? Numbers. You can also have what? Discrete what? Rational what? Numbers. Now, let me explain something. Listen carefully. You know prime numbers now, right? What are prime numbers? Numbers that can do what? That can what?
Itself.
A number only itself and 1 can divide is a prime number. Where does it belong to? Where does prime number belong? Prime numbers. They are numbers. How? Integers, right? They are what? They can be minus, right? They can be what? So they are what? Integers. Now, under integers, you start having your what? Rational number. Sorry, you start having your what? Prime numbers, odd numbers, and what? Even numbers. Remember, prime numbers are numbers only 1 and itself can divide it. 3 of us. Good. Example, 5. Then what you can do to 5 again, except 5 and what? 1. 5 divided by 1 is what? 5. Then 5 divided by 5 is what? 1. There's no other number that can divide 5 to give what? Am I communicating?
Yes.
Good. Now, what is it? Yes. They ask you.
Yes.
Okay, go up and go up. Just go up. Yes. Yeah. Now, We are what? Even numbers. What are even numbers? Even numbers are numbers
That can be divided by
that can be what? By what? Without remainder.
by 2.
By 2. Can you say can even number be divided by itself?
Yes.
Yes. What of odd number? You can list them now.
Yes.
Don't you? It's yeah. Not a 3 or proper 1, right? What next one is what? Odd numbers. What are odd numbers? Number that can do what? Huh? That have reminders are odd numbers. Yeah. Number that don't. What are odd numbers? You don't know what are odd numbers. Oh yeah.
Cannot be divided by 2. It can only be divided by 1 and itself.
Says who? Odd numbers. You know, whatever.
That
Odd number that can only be divided by 1. In prime number now. It's go. Odd number can say who?
odd number, I don't know that cannot be divided by 2.
Okay. Numbers odd numbers are numbers that cannot be divided by 2 without what?
Remainder.
There's no way 2 can divide odd number without what? Remember, anytime 2 divide odd number, there must be what? Remember, I'm coming. What's going on here? Now, we had this, okay. I think we are done with odd numbers, right? Good. Now, these are odd numbers. Those ones are your promises. These are areas I want to talk about. Now, let me start with discrete. When you say that a number is discrete, what it means is that that number is 1. The first thing there is that the number is what is discrete is certain, absolute. This is what it is. There is nothing, there is no continuation. It stopped at a point. Am I completing? This is what it is. There nothing like now if you say 1 is what? 1. This is where it stops. If you say 2 is what? 2. There is nothing like maybe 2.222222222. It's not continuous to any number. If you say 1.5 is what? 1.5. The number, discrete numbers, you can easily detect where discrete number stops. Am I communicating? This number has a kind of limit. There's a particular limit, or there's a particular point it stops. Am I communicating? As against continuous number that you just form the name continuous. You cannot. There's no particular point you can say that it's what. And if you want to write a continuous number, you must approximate it. Am I communicating? Yes. If you want to represent a continuous number, remember numbers and numerals. You want to represent let's assume you want to represent a continuous number in Arabic numeral. You must do what? Approximate it. If not, it will continue going. Something like 1 point, something like this one writing. Something like 1. Yeah. What's going on here? Something like 1.2, 1.333333333, 1.6666666. This number has no end. It will continue like this until it enters what? 2. Are we together? This is not hard. This no, sorry, until it not 2, until it enters. In fact, it has no end, but it will still be within 1 and what? 2. After 1.6, what is the next thing that you think you will see? 1 point what? 1 point what? 7. 1.7. Now, watch now. 1.7. Are you aware that before this 1.6 we get to 1.7, it will get to 1.69? True of us? True of us? Is there any way in this world this thing can get to 1.69? That's why it has no what? End. Are we together? So continuous number, but discrete number, if you want to write this now, you want to represent this number now, you must approximate it to what? 1.6 what? 7. Now, if you want to represent 1.333, you must approximate it to what? 1.3 or 1.33. But look at 1.5. 1.5. This is 1.5. This is just 1.5. Look at 1.25. It's just there. Look at 1.125. Are we together? These ones are, look at 1. 1 is 1. 2 is what? 2. These things are discrete. Are what? Discrete numbers. These ones are what? Continuous what? Numbers. All these things are still here, but you cannot see them. True of us. That's why I said that they are all what? They are all what? Real. They're not integers. Integers are the one you are. Remember, I told you something that in a number line, there are parts you can see easily, and there are parts you cannot do what? See. Those ones that lie between here, you can't pretend them. These ones you are seeing here are what? Integers. Are we together? That's why we have positive integers and what? Negative what? Integers. But these ones are, this one is what? Discrete number. This is what? Continuous number. There are discrete numbers that are rational numbers. And there are discrete numbers that are what? Irrational what? Numbers. Are we together? Are we together? Good. There are also continuous numbers that are what? Rational numbers. So we have discrete rational numbers, discrete irrational. Sorry. What does it now? Discrete rational. Discrete what? Rational number. Now, to better explain it better, let me look at what? Rational and what? Irrational number. Now look at rational number. A rational number is any number that can be present in this form. A over what? B. Any number that can be expressed, express. No, any number that can be expressed in this form, A over B, such that A and B are integers. Such that A and B are integers, but B cannot be what? Equal to what? 0. A rational number is a number that can be expressed in the form A over B. So that A and B are integers. But B cannot be represented cannot be equal to what? 0. When you say that A and B are integers, is 0 inclusive? In integer. But B cannot be what? 0. Do you understand this point and this what I just said now? Yes. That a rational number is a number that can be expressed in the form A over B. A and B are what? Integers. But B cannot be equal to what? 0. Integer number are 0 is there, right? But note the point, B cannot be what? Equal to 0. If B becomes, this means cannot be equal to this thing, right? Equals and slash. This means cannot be equal to what? 0 in mathematics. That's the meaning. What it means is that if you divide any number by 0, The answer is what? The answer is what? Did you do undefined? Did you have you seen something like this undefined? Huh? The question is undefined. Whenever any number is divided by 0 is what? Undefined. Am I computing? Whenever any number is divided by 0, the answer is what? Just undefined. That's the answer. And stop at that level. Undefined. Now, so you cannot get such thing. It don't exist. It's undefined. So that's why we say that. But a b cannot be what? But a can be 0. If you divide 0 by any number, you get what? 0. If you divide 0 by 2, you get what? 0. Divide 1 million by 2, you get what? By 0. You divide 0 by 1 million, you get what? 0. But if you divide 2 by 0, it's undefined. That's the answer. This over b is what? Over 0 is what? Undefined. So that's why I said that a rational number is a number that can be expressed in this form. A over b. A and b are what? Integers. But b cannot be equal to what? 0. That's what we call what? A rational what number. Now from the term rational came from the term ratio. Ratio, which is a same thing with what? Fraction. Am I forgetting? Fraction. Mainly common fraction. Just fraction. So rational, fractions, and rational numbers are the same thing. But there is a reason why we talk about rational number like that. Because you know, when you say fraction, some fractions are common and some are decimal. Common fraction are the ones in this form, a over b. But decimal, a point, maybe 2.4 is a decimal fraction because you have converted to what? Decimal. You have introduced decimal point by removing this divisor. And how do you remove this divisor? Is it divisor we call it? A is what? What do you call A? No, I know. In a fraction in this form, what is you have what is called the dividend, divisor, and the quotient, right? Sorry, not this line is the fractional line, not divisor. Sorry, this is fractional what line? Am I completing? A is the what? B is the what? This is the what? Quotient. Is it clear now? This is the fractional line. Now, this line, to remove the fractional line, you divide this by the what? This. To change it to what? Like, let's say you have 24 divided over 10. This is a common fraction. We'll still do fraction. No? This is a common fraction. But if you divide 24 by 10, you get what? Decimal fraction. Now, let me now go to where I want to go. The point I want to make now. Is 1 a rational number? Is 1 a rational number? Yes. Is 2 a rational number? Yes. Is 0 a rational number? Yes. So, these numbers here are all what? This number you are seeing with your eyes are all what? Rational. Am I communicating? So can we comfortably say that integers are rational? Can we comfortably say that integers are what? Rational, right? We can say that, right? Have you seen why I said if you watch in my when we started this course, I started with continuous and discrete. I stopped. I said, let me come from another dimension, from the one you are familiar with. That by the time we start talking about, you see that those numbers have their place in this discrete and what? Continuous number. Am I communicating? When you go to the computer science, they deal more with this discrete continuum. There you start seeing discrete data, continuous data, but let us not go there. But now you have agreed with me that what rational numbers are, right?
Yes.
Good. But what of rational numbers? Irrational. Irrational numbers are numbers that cannot be expressed in this form. Any number that cannot be expressed in this form is what? Irrational. Now, how do you now know? Sometimes you will be given numbers. You will be given numbers that may be in their decimal form, 2.3, 2.3.93. All these numbers. How will you know a number that is rational and irrational? I want to talk about the test for an irrational and what? Irrational number. Now, there are some terms I want to mention now. I will use it to explain rational, how to know rational and irrational number. The first thing I want to point out is what we call terminating decimals. Terminating decimals. Terminating what? Decimals. We'll still do fraction, but I just want to use to explain something here. Terminating decimals. And we have recurring what? Recurring what? Decimals. Terminating decimals and recurring what? Decimals. Then we also have what pattern. Are we together? This one has no pattern, even though this one has what? Pattern. Under the one that have pattern, we have terminating decimals and what? Non-terminating. This one has no what? Pattern. Let me explain what I mean by pattern. Look at these numbers. Look at these numbers. Sorry, we have terminating just stopped at a point. Terminating just stopped at a point. Under pattern, the one that have pattern. I will explain this since I am listening. Don't crack your brain over it. By the time I start explaining, you understand what I'm doing. Under here, we have recurring. Recurring has what? Pattern and non-pattern. Then under the recurring, there's the one that has single recurring, and the one that has greater than what? One what? Recurring. Let me explain. Now, I will list some decimal forms now. We check all these patterns. Then I will check them in all the decimal form I want to list now. When we are done, I will now tell you the one that you will see. You will know that is a what? That is a what? Rational or what? Irrational what? Numbers. Now, the first one, number like this. You know that rational numbers are integers are rational, but not all rational are what? Integers. Is it clear? Do you agree with me? Yes. Do you agree with me? Yes. Integers are rational, but not all rationals are what? Integers. Is 1.5 an integer?
No.
Is it a rational number?
Yes. No.
1.5. Huh? Good. Yes. 2 2 is an integer and also a rational number. But 1.5 irrational, but not what? That's why I said all integers are what? But not all rational numbers are what? Is it clear? Is it clear? That's what you say. What did this weather water? Okay, tell me where did you get confused? Eh?
How is it? I don't understand it.
You don't understand what? You supposed to speak now.
What you just said.
Okay, what I just said. I say that integers are rational numbers, but not all rational numbers are what? Integers. Some rational numbers are not integers. Something like 1.5, which is 1.5, right?
Yes.
1.5 is rational number, but it's not an integer. Is it clear? Is it clear? Now, good. Now, look up. I want to talk about terminating decimals. This 1.5 now is terminating. You know what is terminating? It stops at a point, right? It stops at a point, right? This is terminating. This is a terminating what? Decimal. 1.25 is a what? Terminating what? Decimal. True or false? It is. 1.125 is a terminating what? Decimal. You can move 1.5 from decimal fraction to common fraction. Yes. 1.5 is what? Is what? No, it's not half. It can't be half. Lie. It's 3/2. Check it now. 1.5. Call this point what? 0. 2 goes. Simply 5. 5 goes here is what? 5 here is what? 1 number 1/2. 1.5. Have you seen how I moved 1.5 to what? 1.5. This is a common fraction. We'll still do common fraction and the decimal fraction. But I just want to mention it to be able to explain rational and irrational what numbers. Now this is 1.5. This is 1.5. 1. So this number now, this 3/2 or 1/5, if you move it to decimal fraction, is a terminating what? Decimal. The same thing, if you change this now to a common fraction, you'll be getting around what? 1/4. Some are lost. Learn how to play with numbers. Decimal, please, not all numbers. Decimals. Yes, it stopped. Look at it now. It's 1.5. It's not 1.5555777. Hello?
So it's safe to also say
It's a discrete number. But terminating decimals are discrete. But is it all discrete numbers that are terminating the decimal?
No.
Some are not even some numbers are not decimals, true or false? But they are what? Discrete. Integers are discrete. Are they the decimals? Am I communicating? Now let's continue. Now here is 1.25. I said that I converted this now to common fraction, and it gave me 1/4. So I'm looking at me confused. How it happened? And this is 1/8. So I'm still looking at me how it happened. It's simple now. This is if you shift this one now, what you mean here is half. 0.5. It's not true.
Yes.
Which is half. That's why here is half. This one here is the whole number. 0.5. 1.5 is certain as say 1 point plus what? Do you agree with me? Simple. This is what? Half. This is 1. That's why it's 1/5. Now here 1.5. 1.25 is said now as 1 plus what? 0.25. And if you divide 0.5 by 2, you get what? 0.25. True or false? Then divide 1/2 by 2, you get 1/4. That's why here is what? 1/4. Each of you can simply take the longer route. Make this 1 25 over what? 100 and keep dividing. If you divide finish, you end up in what? Here is what? 25 divide 100. You get what? 25 divide 125. You get what? Huh? This is simple mathematics. I promise you mathematics. You are looking at me like as if you are looking at a ghost. To 100 divided to 25 is what? 4 now. You use the same 5 to divide 125. It will give you what? This is 5 now, which is Satan now saying what? It's why I'm giving you shortcut. You don't need to go and start doing all this in any program. If you get that, you're not in school. Learn how to play with numbers. Some of you, numbers are still playing with you. Yes, it's a fact. It may read somehow, but it's fact. Start playing with numbers. Then numbers will obey you. You can just close your eyes. I used to tell people that this is jokes apart. Is practice. Is constant what? Practice. Put your hand. Don't kill yourself with calculator all the time. It's a wrong thing. It damages your normal, your natural thinking. It just destroy it. You can't reason again when you see question, when you see some certain things. So it's not everything you carry a get and putting up and no, it's not everything. There's some things you can look at. But it doesn't come all of a sudden. It's a constant what? Put conscious effort. Tell yourself, let me keep the calculator by the side. And see how far I can go. Gradually, you start seeing that there are some things you can easily look at. I used to tell people that when I wrote my post-UME that led me to UNM. We entered all. What's a calculator? I wasn't even solving anything. So just look at the question. PM. Answer. Look at it. See the answer. See the answer. You look like maybe I was just exaggerating. I practice these things. Practice. It's not magic or boasting. It's practice. Look at number. Number will obey you. Haven't you seen people that have gone to mathematics competition? They'll stand. They're not punching anything. They give them a question. They look at it. They tell the answer. It's not magic. It's not staged. They didn't stage it. It's life. They didn't stage anything. Under 5 seconds, you must give the answer. It's not magic. And the first step to achieving that level is to tell yourself, this calculator, stay by your side. Let me see. Calculator was produced by a human being. True or false? God gave human being that brain. See how we are killing ourselves. See that we are making life easy. God gave human being that brain. Calculator is garbage in, garbage out. It's human being out there that put that thing you here are using to punch. And they keep you dull. You are punch calculator. When you are not able to see calculator, you cannot do anything again. That's so bad. Now let's continue, please. Now the same thing here. This is if you separate this now. Look at it. This is that I say 1.0 point what? Do you agree with me? Do you agree with me?
Yes.
Good. And this 0.125 is half of 0.25. True or false? True or false? Divide 0 by 2, you have what? 0. Divide 2 by 1, you have what? Divide 0.025 by 2, you have what? 0.25. You have 0.125. True or false? Now, what it means that if you divide 0.25 by 2, you have 0.125. And 0.25 is 1 over what? 4. Simply divide 1 over 4 by 2. 2 will come down and multiply what? 4 under the denominator. You have what? 1 over 8. That's why here is what? 1 number what? 1. So now the point I'm making is that this number, sometimes the number may be, so that the number may be in fraction, in common fraction, and you're asked to check if this number is terminating what? Decimal or recurring what? Decimal. Once you divide it, if it stops at a point without you approximating it, that's the point. If he gives you an answer without you doing what? Approximating it by yourself is a terminating what? Decimal. Did we approximate anything to get 1.5? When we divide 3 by 2, did we approximate? That is a terminating what? Decimal. Did we approximate 5/4 to get 1.25? That is a terminating what? Decimal. Now, this is for what? Terminating what? Decimal. Let me get another linkage. Terminating decimals, are they discrete?
Yes.
Are they discrete?
Yes.
They are discrete, right?
Yes.
Good. So they are not continuous, right?
Yes.
Good. Now let's now go to what? Recurring what? Decimals. Recurring what? Decimals. Now, recurring decimals are not discrete. They are continuous. Hello? Recurring decimals are not what? Discrete. They are what? Continuous. Recurring decimals are not discrete. They are what? Continuous. Both recurring decimals and terminating decimals are rational numbers. Both recurring decimals and terminating decimals are what? Rational numbers. Do recurring decimals have pattern? Do they have pattern?
Yes.
Do they have pattern?
Yes.
I will explain what I mean by pattern. The pattern can be single, recurring. The pattern can be maybe after 1, 2, 3. You see the same number again, coming back again. Have you seen a decimal number like that? Don't worry, I will give you some example now. Are you done? Can I clean this board?
Yes.
What is it?
We see a female that now this thing a terminating decimal. I don't understand.
If you divide a number in a common fraction, let's say 3 divided by 2, or let's say half, 1/2, right? If you divide 1 by 2, and it will give you a number that is in the decimal point, in decimal form. If you don't get that, if you get the answer without approximating, that means it's terminating. It ends on its own. Terminating means what? Endless. For the two of us, it ends on its own without approximation. That number is what? That decimal is a terminating what? Decimal. Is it clear?
Yes, another one. This thing I know if now 1 plus 0.25 is also equals to 1.125.
No.
But 1.1 is it not 1 plus 0? 1 plus 0.
Okay, plus. Okay, continue.
It's also equals to 1.125.
1 plus 0.0. Say it again. Call it. Let me write it down.
1 plus 0.125.
Okay.
And it's equals to
1.125. Yes.
This day way is yellow, but like this one is now.
Okay.
Yeah.
Okay, you mean 1. Okay, you mean. I think at this point I need to clean some part of this board. You mean this one, 1.25, right? Yeah. It's equal to 1 plus what? 0.25. 0.5. Is that what you mean? Okay, I started from here. That 1.5 is equal to what? 1.1 plus what? 0.5. That's what I started, right? And I asked you, put that 0.25 in common fraction. What is it? 0.5 in a common fraction. Is half 1/2, right? Plus what? Which is a sentence saying what? 1 over what? Do you agree with me?
Yes.
Now, I will now have 1.25. You said now saying what? 1 plus what?
0.25.
Look at these two numbers. If you divide this by 2, it will give you what? Do you agree with me? that if you divide 0.5 by 2, it will give you 0.25.
Yes.
Do you agree with me? Do you agree with me? Now, if that is the case now, since this one already is what? Since half 0.5 is already half. And if you divide it by 2, you will get 0.25. That means this is certain as saying half divided by what? 2. And remember, we still do fraction, don't worry. For those that we know them, don't worry, you will learn all this here. Oh? Don't be afraid. Now you have what? 1 over what? 2. To change this will change to multiplication. And this will do what? Invert. True of us, you have times what? 1 over 2. This is what? 1 over 4. That means you can replace this 0.25 with what? Plus what? The answer is what? Is it clear now? What is not clear?
That's the one you just did, like, not clear.
Okay, where we are, where exactly?
You say that this 0.25, that if we divide that 0.5, that it will give us this
0.25.
like,
So, and the 0.5 is what in common fraction? 0.25 is what in common fraction? We said half divided by 2. That's what we do. We did the half divided by 2. Since in car divided by 2 will give you this one. So you now do half divided by 2. You solve the calculation and got 1 over 4. So that means this 0.25 is actually what? 1 over what? 4. True of us? 0.5 is what? 1 over what? 4. Now you add it to this one. You have what? 1 whole number, 1 over what? 4. Is it clear? Is it clear? Is it clear? Who is lost? So where are you lost? You don't understand anything here. Huh? Which pattern?
This pattern.
Is what?
You use more of brain power than doing this on our own.
So do you have a better way?
This old one is the pattern.
Which old one?
The one that is for instance 1.25 divided by 100.
It's okay now. That one is okay. It's your choice. Anyone want to use it's okay. Huh? It's their business. I've told you what you see. See, hello. The worst that can happen to you is that if your lecturer stand in front of you and tell you what to do, you keep doing what you think you know how to do. Continue with time, you understand what is better. The point now, as I mentioned this, a wise person should start thinking, how do I start this thing? On what is it?
What if you have a number like 6.25?
It's something. It's something now. The problem is that most of you don't even know that 6 point. Do you know the issue? Most of you don't even know that 6.25 is certain as saying 6 plus 0.25. That's the problem.
Okay, so the answer should be 6 over
1 over 4. Simple. See, I understand where the problem came from. Don't be. Sometimes if I say these things, some people think I am embarrassing some people. Our education system is in a mess. Our education system is in a mess. Some of us parade certificates obliging there. Malpractice has been institutionalized in secondary school. During our own time, in C6, you are too powerful. Yes. In C6 now, for real, jokes apart. In C6 throughout, from 2000 up, let's say 1999 down, or some 2000 anyway. Go and sit down in person and discuss what I'm talking about. During that time, exam practice, only few people, far place. They can't do it in the city. During that time. So only just few percentage that's how work. And Majority, they work by themselves. So that time, you know what A1? Do you know what is A1? A1. Me here. Udi ke in para secondary school. I purely competition. I pure competition in Number State. There's no competition again now. That's what I'm trying to revive. We grew with competitions. That's how we grew from different competition to the other. Ikedi de mon atacha na Number State. Apart from chemistry A1, mathematics B2, physics B2, other courses credit. And I have money to blue wire A1 Julia. No, jokes apart, for real. Let's keep the joke. It's not a joke. It's a new problem. Hello? Edu? It's a big problem, seriously. Sometimes some people don't understand it. They will think that this man is talking too much. But it's a fact. So, and do you know the effect of this? Do you know the effect of this? The effect of this is that it will make you, there are some things you equal mortar at that stage mortal. So when you come here, you won't understand what they're saying. And the part is most of us oppose our fault because all the go me and village but how was the schools no, on a more serious note, they have graduated and they opened their own schools. So they have now brought it to their own school. Nobody questions them. Most of these corrupt aviators are all had a hotel. And exam. Our country is going down by day. If I say this, people think I'm joking. If I say this, people think I'm just talking too much. It's a reality. Nelson Mandela, the whole world revered today. I keep quoting this man anywhere I go. He said, if you want to destroy a nation, don't even go and buy bomb. You're wasting your time. Just go and destroy their education system. And he didn't stop at that level. He said, he not just, he now told us again how to destroy the education. He said, allow students to cheat in examination. Period. That's what the next. Go and browse online. Google it online. You see it. Or see no, allow students to cheat in examination hall. That is the origin of corruption. A pharmacist that cheated will come out tomorrow and keep cheating where he's working. A lawyer that cheated, jam cheated, or by school, everything about him is cheating. Will take bribe. An engineer that cheated and graduated will go and take the money he was given to do whatever he want to do and produce or even construct nonsense. Because conscience is gone. Quality, standard. It goes in all aspects of life. A politician that cheated throughout the university and entire school, Mr. Buying house, Ghanezu, or told him you nako. You don't understand what they're saying. So please, I keep advising people, if you know that you are one or a product, if you know that you are a product of this nonsense, better help yourself on time before it becomes too late. Now let's continue. All I know is that whatever I say, I tell you today, tomorrow, you remember I say this. What you leave behind is what people remember you for. No matter what it is. Throughout my secondary school, school. Now you dare not ask me question exam. And I said, don't even go to the, but you can call him anytime, he will teach you. But don't even say in a damn hall. He will even report to you. And I tell me, you must have a standard for your life. Some of you may not want to do it because you say, I'm going to get the hostel. I said, I'm wicked. I talk to me, the whole school, yes, don't exam. Leave the standard, don't even go there. But if you don't understand something, go to him, he will teach you. So exam standard. It's okay. You must have what people know you for. Stand for something. If you don't stand for something, you do what? You fall for anything. If you don't stand for something in your life, you fall for anything that comes your way. Mark this sentence. If you don't stand for something, you can easily fall for anything that comes to your life. Now let's continue. The what next we are talking about is what? Now, recording decimal has pattern. Now, let me explain what I mean by this pattern. Watch. We say, I told you that recurring decimals are continuous, right? Yes. They are not what? Discrete. Do you agree with me? Yes. Now, let me get some. Let me get some fractions that are recurring. Something like 1/3. 1/3. Something like such you. No, don't even need to punch. Let me do it because now good, yes, sometimes. Don't punch on me. Now look at this number. Hello, 1/3, right? Now watch. These numbers are in what? Base what? 10, right? Remember number basis? Yes. Base 10. Now let's go. 1 divided by 3 is what?
0.
Is what? 1 divided by 3 is 0. Remember 1. Okay, just be listening to me. Just listen. Let me do it. 1 divided by 3 is what? 0. Right? Remember what? 1. Good. Now, because this number is less than 3, you put what? Decimal point. Am I completing? Then multiply the remainder by the number base you are working on. We are working in what? Base 10. So multiply the remainder by the base you are working on. Remainder is what? 1. 1 times 10 is what? 10. Right? You keep dividing. 10 divided by 3 is what? Number base. And I said that you divide 1. I want to teach you something now. Just listen. Apart from your long division you're doing in primary school, I want to teach you a very fast way to do all these things without wasting your time. This is 1 divided by 3 is what? 1/3 is 0. Remember what? Because 1 is less than 3 is not 2. So the answer is what? 0. Remember what? 1. You multiply that remainder by the number base you are working on and keep dividing. Just divide. Get the other part. Get the remainder. Multiply by the what? Base you are working with. And I ask you the first question. This number is in base what? 10. Normal number you are working is in base what? 10. So this is 1 divided by 3 is what? 0. Remember 1. This point enters here because everything here, this is less than 1. So you're not entering the decimal. Am I completing? So now that 1 divided by the number, the base you are working on, which is we are working on base 10. 1 times 10 is what? 10. Then continue dividing. 10 divided by 3 is what?
3.
Huh? 3 what? Remember 1. You multiply by the base again. It becomes 10. You keep dividing. Multiply again. You keep dividing. Multiply again. You keep dividing. Yes, again, man. If you keep going, 3, it has no end. Are we together? Now, this is what? A recurring decimal. But it's a single recurring. Look at it. It's single. just after this one number keep repeating itself. That's why I mentioned what? Single. It keep doing what? 3 keep doing what? Repeating it what? Self. Good. Yes.
This thing that you just wrote, is this thing single recording? Yes.
I just said it. No. Here, no. I can't play. No. Go see. Check it. No. Check it. What are you thinking about? It's okay. I said it now. True or false?
True.
That is what single what? Recording. Because after that one number, it keep coming back in. That was single what? Recording. Now, let's look at 4 by 7. All right, let's use the same pattern we did here and divide 4 by 7. Let's go. It's less than 1. Good. So you should what?
0 points.
So 4 divided by, so the remainder is what? No, look at it. 4. 4 divided by 7 is 0 remainder what? 4. Then multiply by the base. 4 times 10 is what? 40. Then keep dividing. 40 divided by 7 is what?
40 divided by 7.
7 is what? So how many 7s as a whole number can be in 4? In 40, eh?
5.
But good. Could confirm. So the answer here is what? 5, right? Remember what?
5.
Multiply that remainder by the number base you're working on again. 5 times 10 is what?
50.
Keep dividing.
50 divided by
7 is what?
7 is 1.
Good. 7 remainder 1. Multiply the remainder by the base you're working on. 10. Keep dividing.
1 remainder 3.
Multiply again by 10.
4 remainder 2.
Multiply again. 20.
And 2 remainder 6.
2 remainder what?
6.
Continue multiplying. 60, right? Divide by 7. Oh yeah.
Yes.
60 divided by 7 is what? 56. 8. Is it 8? 7 times 7 is 49. Plus 7, 56.
Yes. 8 remainder 4.
8 remainder what? Good. Multiply again. 40. 40 divided by 7.
5 remainder 5.
Keep going. Just be doing it. I want to show some. Just keep going.
That is 7 remainder 1.
Continue going.
1 remainder 3.
Continue.
4 remainder 2.
Continue.
2 remainder 6.
Continue going.
8 remainder 4.
Look at this number. You first of all punch 4 divided by 7. What is the answer? Punch a character and compare what we got. Do that first.
0.5714285714.
Is it something?
Yes.
Is it something?
Yes.
Now we are past that stage. Now look at this number. Look at the pattern. Is there a core in there?
No.
It's not true. Look at it again.
Yes.
Where did it start repeating itself again? After here, you still have it again. Now after here, 5, 7, 5, 7, 1. This is what it will keep doing. After 8, 5 will enter again. This is what you keep doing, till infinity. This is a recording, but it's not single. After 4, 1, 2, 3, 4. After 4 digits, 5 digits, 1, 2, 3, 4. 1, 2, 3, 4, 5. After 6 digits, it will do what? Record again. It's recording, but not single, unlike this one. These numbers that give you a decimal, recording decimal, whether single or not single, is also a rational number. Because it has a pattern. It's also a what? Rational number. But it's a what? Continuous rational number. True or false? It's not discrete, but it's rational. So this type is what? Continuous rational number. Basically, it's a rational number, right? But this type is what? Continuous. The other one we say 1 or 1.5. is discrete rational number. True or false? True or false? Good, but this one is continuous. So a continuous number can be what? Rational. So we have discrete rational number. We also have continuous rational number. So this one that have pattern, whether terminating or decimal or recurring, whether recurring or terminating, they are all what? Rational number. True or false? Now, but irrational number has no pattern. Irrational number has no what? Pattern. A sword is an irrational number. Do you know why you did sword in your first semester phase C, right? Do you know why you keep hearing rationalization of sword? Do you know why? Because sword itself is what? Irrational. Pi is what? Irrational. Pi is what? Irrational. What is the value of pi? See.
3.142.
Is pi 22/7? Is pi 22/7?
No, 3.1.
Is pi 22/7? But it's not true. That's what you are told in your secondary school. But in real sense, pi is not 22/7. Pi is irrational. 22/7 is rational. Let's do it again. I'll divide 22. I will use this pattern now. Divide 22/7. List here the value. Then you punch your calculator and check the value of pi. You compare the two of them. You will see whether pi is rational or not. Are we together? Are we together? Let's do it. Check 22/7. First of all, check pi for us. Punch your calculator and tell me the. Don't approximate.
3.1.
Come down. Check pi.
3.141.
3.141592 65 35 9. Well, was that right? Look at this number. Is there a pattern? Is there a pattern here? Is there a pattern here? Is there a pattern at all? This is pi. Pi is irrational number. It has no pattern. Are we together? Pi is irrational. It has no, the decimal form has no what? Pattern. Now let's look at 22/7. Let's divide 22/7. Right, let's do it. 22/7 is what? Okay, 22/7. Let's do 22. Hope people can do this thing you are doing on your own. Let's do 22/7 is what? 3 remainder what? Remainder 1, right? Remainder 1. So 1 times 10 is what? Okay. Divided by 7. Remainder what? 4. It's 3. So 3 times 10 is what? Divided by 7. 2. 2 times 10 is what? Divided by 7 is what? 6 times 10 is what? I'm coming now. I'm going to the Bible 22/7. I'm trying to show you that I understand something. We saw about 60, right? Divided by 7 is what? 4 times 10 is what? 40 divided by 7 is what? Times 10. Keep going. 7 remainder 1 times 10. Again. Times 10. Times 10. 8 Are you sure? Yes. 7. Now look at this number. Hello? Look at 22%. Is it a pattern?
Yes.
1, 2, 3, 4, 5, 6. 1, 4, 2, 8, 5. 22/7 is a rational number. But pi is not a rational number. Someone should punch 22/7 and tell me whether it's this thing. Is this something? So is pi equal to 22/7? It's not. For convenience in your secondary school, they approximated it into 2 decimal places and told you assume pi to be what? I'm coming. Okay, I forgot. Root 5 is what? 2 point what? 2.23. I'll go. Look at this number. Look at root 3, root 6, and root 5. Is there a pattern? Is there any pattern?
No.
There's no pattern there. So a surd is an irrational number. A surd is not a rational number. I gave you 2 examples of irrational number. I gave you root 3, and I gave you what? I gave you surd, now root 3, root 5, root 6. And I also gave you what? Gave you what? A pi. So pi is an irrational what? Number. A surd is irrational number. Yes. You can test any of that. This is mathematics. It's a free. You can test as many as you can to confirm. We have tested how many here? 3. You can test as many as you can to confirm it. Simple. It's not true. Then if you see anyone that is a surd that is a rational number, then it may give room to more research and more this thing to find out why that surd is what. Maybe from there something new can come up. It's not true. That's how a scientist think. Scientists don't just reason at level or let me pass the exam. You think out of the box. It's very important. It doesn't an it's all meter. It was a 1. It was, okay. See, na kena bozi what are until solo me or you say where can I want what are the answer? Anyhow, I want to understand it. It's okay, it's allowed. Now, so those numbers are listed. Is there anyone I've not talked about? Check those numbers are listed. Is there anyone I've not talked about? Huh?
Sorry, so these sorts are also non-pattern decimals.
Yes. That's why they are irrational, because it has no pattern. Yes, they have no pattern. Another step. I like making dropping statement that will help you to understand a lot of things. Once you know that statement, you are good to go. Another statement I want to make now is this. Another statement I want to make now is this. Rational numbers. Decimal. Rational numbers can be decimals. True or false? But not all decimals are what? Rational numbers. Hello? Rational numbers can be what? Decimals. But not all decimals are what? This thing, are they not the decimals? Are they rational? No. Are they rational?
No.
So because they have no pattern. Only decimals that has pattern. And that are also terminating. Only terminating and recurring decimals are what? Rational numbers. Because recurring decimal has pattern. True or false? Yes. Terminating just stops. Yes. But But decimals without pattern are what? Irrational. Are what? Irrational numbers. You know, the topic we are treating is numbers and what? Numerals. So if we want, even though we will treat, I would have continued from rational numbers and enter fraction. But I don't want to do that because we have a topic for that, okay? When we go to notation, that topic is under what? Notation. So I don't want to go into that now. So the next area I want to go is numerals. I want us to look at numerals. So we are done with numbers. So I can come anytime, draw a question on numbers. So better go and study numbers. Can come here, list your numbers, say identify and go. And in Portuguese, we know that record. See a real. So for numbers, I'll give a pattern of questions I can come up. I will solve a question. Remember, I said that I will solve a question before. Are we there? So I'll give you. You just do work. You just show examples now. I'll test your knowledge on the examples before I can now start giving you your assignment. So the assignment I was including a jack of people. No, but I is that here? Mark is that Mark and fly. Now I'll list some numbers now. Then ask question there. Then let's see how far we can go. I'm not scaring anybody. I will just answer it. Let's see how far we can go. Let's see what we've learned from everything we've been saying here since. Now I want to list some numbers. Now look at this practice example I want us to look at. Okay. I'll list these numbers. The first one is what? 3i. 2 plus what? 4i, comma, 9, comma, 2, comma, root 7, comma, pi, 22 over 7 is common up, 1 over 8, 1 over 3, 0, minus 4, and what? 7. How many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 numbers. Now, the question says, from the numbers listed above, choose examples of the numbers below. For numbers listed above, choose examples of the numbers below. So these numbers are the first one. Question. Write this one first, then write the question. For numbers listed above, choose the examples of the numbers below. The first one is complex number. The first one is what? Complex number. The second one is number or numbers. Hope you know what this means. Yes. Now it can be more than one. What this question means that these are questions, the type of question I ask under numbers. Look at, I ask under number. I can change it anyway, but once you understand what is there, you can answer. What this question means is this. Now, complex numbers here, what it means is that you must, for you to get your mark, you must list all the complex number here. If you miss one, you have failed that question. If you miss one here, you have failed. So you need to be what? Articulate. Don't do this anyhow. You need to be what? Articulate. Pick all the complex numbers. But we are not told to give examples. It was listed here for you. You should be able to identify the what? Not two, all the complex number here. That's what this question wants you to do. Then the second one is what? Imaginary number. The third one is real number. The fourth one is discrete numbers. The fifth one is continuous numbers. The fourth one is, sorry, don't mind me, 6. Discrete. I'm coming. I know what I'm doing. Discrete rational numbers. I know what I'm doing. Number 7. Rational numbers. Number 8. Irrational. After this till I'll go. In the next class, we'll start with what? Numerals. Okay?
Yes.
Irrational numbers. Good. Number 9. Yes. Okay. Number 9. Continuous rational numbers. Number 10. Whole numbers. Number 11. Natural numbers. Number 12. Integers. Number 13. Prime numbers. Number 14. Odd numbers. Number 15. Even numbers. Let me see if I can add one more number. Sorry, this is rational, not ration. Please, rational. Please, rational. It's an adjective. It's an adjective, not a noun. All right, so let's go. Let's look at these numbers. Who can tell us the complex numbers here? I say who. I say who. Who? If you know you raise the hand, I say who.
2 plus 4i.
Complex number 2 plus what?
4i.
Do you agree with her?
Yes.
I agree. Because a complex number has what? Real number and the imaginary number. True or false? Good. The real part is 2. The imaginary part is what? 4. Good. So we have only one complex number there, right?
Yes.
Good. What of imaginary numbers? 3i. Do you agree with her?
Yes.
What is the value of I? Root minus 1. Okay, put it in under root sign. What should it be?
3 minus 1. 3 times minus
1. Minus root 9. Root minus 9, sorry.
Okay.
Did I do it here?
Yes.
Root minus 9. So you putting 3i in under those signs, what? Root minus what? 9. Because this thing is certain as saying what? Minus 1 times what? True of us from your rule or third rule, right?
Yes.
So here is what? I is minus 1 is what? Root 9 is what? So answer is what? Is it clear?
Yes, sir.
Please know these things. So the major number is only 1. 3i, right? Yes. Good. What of real numbers? If you know it, raise your hand. John the. If you know it, stand up, raise your hand, let me point you so you can tell us. Oh yeah, boy. Real numbers are what?
Numbers are
9. 0.
0.
Who disagrees with her?
For which thing? Real number.
She said 9. 2.
Minus 4. 7.
Who disagrees with her?
Nobody.
Real numbers.
Yes. That the numbers in the number line, whether negative or
Who disagrees with her? Hey, what a woman, because. Are you serious?
yes.
Have you forgotten the invisible parts?
1/8. 1/8. 1/8.
Numbers are divided into two major groups. Two major groups are what and what?
Real number.
So remove imaginary and complex. What is many here?
Real numbers.
Remove here. Everything here is what? This is imaginary. 2 plus 4i is complex, which is imaginary plus real number.
Yes.
Another thing from here is what?
Real numbers.
So when you get out, you judge that. I don't work examples. There's no community. You after that. Mark, you may fly. Boom. It was the rest of it. Now 1 year. So the answer is what? 2, 9, 2, root 7, pi, 2/7, 1/8, 1/3, 0, minus 1, minus 4, and 7. These are the real what? Numbers. What are discrete numbers? What are the discrete numbers here? What are the discrete numbers? If you know it, just raise your hand. And tell us the discrete numbers here. Just remove complex and imaginary. Real number. Discrete numbers there. Call them. Who knows? Oh yeah.
1/8.
Let's just, if you call out right.
1/8.
1 over what?
3.
22/7. Is that all? Root 7. Is that all?
9.
Who disagree with her? Oh yeah. Tell us your own. Fast.
Okay.
The discrete numbers. She's still on this. 9.
Like everything they should be.
Madam, call your own.
Okay.
Just call.
2. 1/8. 1/3.
7. Is that all? Who disagree with her? Rule 7. Discrete numbers. Who disagree with her? You disagree with her? Call your own. Call your own. Someone has raised a hand. Oya. Call your own. 9, okay? 5, whatever. Okay, pi. Okay. 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 7, whatever. Okay. Is that all? Who disagree with her? Who? Did you disagree with it? Yes or no? Did you disagree with her? Okay, well done. Don't tell me. Just did you disagree with her? Yes or no? You disagree with her?
Yes.
I call your own. Oh yeah, fast. 1 over what? 7. 3. Okay.
-4.
Okay.
0.
Okay.
So 7.
Rule 7. Okay.
7.
Okay.
0.
Who disagree with him? Do you disagree with him? Oh yeah. Call your own. 9. Okay.
2.
Okay.
1 over 8.
Okay.
0.
Okay.
-7.
Okay. Minus what? 7.
-4, sorry.
Okay.
And 7.
And 7. Who disagree with her?
Wait, sorry, excuse me.
Who disagree with her? Who disagree with her? I say, hello. Who? Don't explain anything. Just who disagree with her?
She's correct.
Any distinct counter opinion. Okay, now let's look at what she did. Let's take it step by step. 9. Is 9 a discrete number?
Yes.
Yes, because 9 is 9. One of you stop at 9. True or false? 2. So 9 is there. I agree with that. 2 is 2 a discrete number?
Yes.
Because it stopped at 2. 1 over 8 inco?
Yes.
No, is this a discrete number?
No.
This one inco?
No.
This is root 7. Root 7 is what if you punch it, it will give you blah 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 till it's continuous, right?
Yes.
Pi is also we did pi here, it's continuous, right?
Yes.
2 over 7 inco? It's continuous. 3 point blah 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 is continuous. 1 over 8 inco?
0.15.
Is it continuous? Is this with good? And she wrote it here. 1 over 3 inco? Is continuous. 0.33333. Good. It's continuous. 0 inco is 0. 0 is continuous to where?
No.
It's discrete. -4 inco? Discrete. 7 inco? She got it. So let's clap for her, please. Now let's look at. So how many people have got our answers here? Make some. Okay, I'll just write a serial number. 002. Okay, yeah? Who got imaginary?
021.
Imaginary. Who got imaginary? Okay, imaginary. Okay, 021. 008. Now let's look at. Who got the numbers? Nobody. Who got the numbers? Nobody got the numbers. Nobody. All right, let's look at this continuous number. Who? Okay, if from where? Wait. Call continuous number. Rule 7. Okay.
22 over 7.
Rule 7 and what?
5.
Good. Okay.
22 over 7.
Okay.
1 over 3.
1 over.
3.
Okay. Is that all?
Yes.
Who disagree with her? Nobody. Good. So this is rule 7. It's continuous. It's continuous, and there's no other continuous numbers here apart from this, and what this. So she got it. So if you are 07, okay? Okay, good. Now, Hey, those really are one year. And those here that I know la. Oh yeah, she raised her hand first. But you calm down now.
No, I
You
didn't calm
you
down.
became confused and stopped raising your
No,
hand.
I didn't get confused. Though.
But in this one now, she raised her hand first.
No, I was the first.
Next question is what?
Discrete rational number.
Discrete rational number. Oh yeah. You allow that, right? Oh yeah. Call your discrete rational number. Your own. Let's see whether it will become our own. Call your discrete rational numbers here. Oh yeah. Call them.
I thought you saw numbers.
Oh yeah. We are following like this. That's not you. We are done with this one, right?
Yes.
We are in discrete. Oh yeah. It is oh yeah. I call them. One over what?
8. Rule 7.
Rule 7. Pi. Okay, I'm waiting.
20 over 7.
2 by 7. Is that all? Who disagree with her? I will take the oil.
Discrete rational number.
Wait. I call it 9. Okay. 2. Okay. You're a very human being. No husband. Just tell me your answer.
9, 2, 0, -4, 7, 1 over 3.
Is that all? Okay. Is that all? Is that all? Who disagree with her? Who? You disagree with her? Thank you. Oh yeah, call your own. 9. Okay. 2. Okay.
0.
0. Okay.
-4.
-4. Okay.
7.
On it?
7.
7. Okay. Is that all? Because who disagree with her? Who disagree with her? Who disagree with her?
Those projects.
Uzugo for 19 project for 5.
The 5 are better.
The not for.
Can you define?
Yeah, every man is on. Mr. Can check his records. Who disagree with her? Who disagree with her? The question here is wait. Who disagree with her?
I disagree.
Okay, why disagree with her? Let's start from her. Why disagree with her? You only see a number now. You only see there.
Okay. Why disagree with that? Discrete rational.
One has, please. We are this not important here, please. One has, please.
Rational numbers are also numbers that can be expressed in fractional form. And discrete numbers are numbers that stop at the point. So why is 1 over 8 different?
1 over 8 is supposed to be. Let me do my own.
Okay, you say that 1 over 80 is not there.
Yeah.
Good. Remember, I'm not through yet, right?
No, it's very true.
No. I asked a question. I said, hello. I say who disagree with her? Go ahead, but this is your own now. You already called now.
It's my point now that I disagree. You now know give somebody.
Anti-rest. Another person.
I feel like this.
Disagree with her. If you disagree, call your own. If you have called once, just rest.
Follow up with us.
9.
9. Okay. Wait, I'm coming down. Okay. I beg you. Yeah, okay, I wanted her to come so I can give it to her. Chalo. Let's start.
9.
What are we looking for?
Discrete rational number.
9,
1/8. 0. 4. 7.
It's okay. Who agree with her? Sorry, who disagree with her? Sorry. Okay, so you all agree with her. Victoria. Now, okay, let's check whether it's true. Now let's go back to the list of numbers we have. So this key number means numbers that are discrete at the same time rational. Are we together? So these are numbers you will list. They are discrete at the same time what? Rational. And we know that discrete is 1. That's what it is, right?
Yes.
Then rational. Rational must have recurring decimal or terminating decimal. Remember, if it is in a fraction, pull it to decimal fraction. If it's a common fraction, push it toward the decimal fraction to check. This is how to test too. This is how to test whether a number is rational. If it is in fractional, if it's in common fraction, like 1/2 something, move it to what? Decimal fraction and check whether it is terminating or recurring. If it's terminating or recurring, whether single recurring or the other form of recurring, all now what? Recurring. If it's terminating or recurring, it's a rational number. Now let's look at it. Of course, when it moves to recurring, or was continuous, it has left continuous. Or was it discrete? It has left what? Discrete. It's not continuous. So whether recurring or recurring or single recurring or anyone, or was discrete too, it's now continuous. So discrete doesn't even have any word recurring. The decimal must be what? Terminating. So a discrete number can be a rational, but it must be what? Terminating. That's a very important point. Okay. Now let's take them one after the other. 9 can be expressed in form of 9/1, true or false. So it's a rational number. At the same time, it's what? Discrete. True or false? 2 can be expressed as 2/1, right? It's still rational. At the same time, what? Discrete. Rule 7 is continuous, but not what? Rational. True or false? Is continuous and irrational. Do you agree with me?
Yes.
Who doesn't agree with me? That rule 7 is continuous and irrational. Rule 7 is it a sword?
Yes.
The sword. And I told that swords are what? Irrational. So and it's also continuous. True or false? So it's continuous and irrational. So it's not the answer. So we'll leave it. Go to pi. Is pi continuous or discrete? It's continuous. At the same time, so it's not the answer. We move to 22/7. Is 22/7 rational or irrational? Is rational but continuous. It's not discrete. True or false? So it's not what I'm looking for. 1/8, is it rational or irrational?
Rational.
1/8 is rational. Is it discrete or continuous?
Discrete.
Because it's 0. What? So it's what? Discrete. So it should come here. Is what I'm looking for. 1/3, is it rational?
No. Yes.
But no, so it's not discrete. So leave it. 0 uncle.
Yes.
Rational, discrete. So that's why 0 came in here. -4 uncle. Rational and what? Discrete. -4. 7 uncle. Rational and what? Discrete. 7 enter. So this person missed here 1/8. Who gave us this?
005.
Okay, 0.5. Well, yeah. 0 what? 0.5. So she got it. This is one miss only. If this is the exam, you have failed this one because of that one number you missed. So be careful as you are picking your what? Numbers. Be careful as you are picking your what? Numbers. Don't just close the eyes and write anyhow. Now, rational numbers. So let's list. You want to answer? Huh? Answer rational number. Oh yeah. What are rational numbers here? So what are rational numbers here? Oh yeah. 0, 1, 3. Oh yeah. Tell us now. Huh? 27.
No, sir.
Okay, root 7. Rational numbers. Okay. Huh? 5. Okay. Is that all? Call them all. 2. Okay. Is that all? Who disagree with her? Aboya. Rational are what? And what? Who agree with her? Who disagree with her? Eduoya. 9. This is 002. This is 013. This is 030. Oh yeah. Mm-hmm.
0. One of one is 1.
I'm writing your serial numbers.
The first person is 1.
Forgive me. It's 013. 0 what? 02. Oh yeah. 9. 2. Root 7. Okay. 1 over 8. 1 over what? 3. 0. Minus 4. 7. Who disagree with him? Who? Hey! 019 has woken up. Oh yeah. 019 has woken up. Oh yeah. 9. 2. 1 over 8. 1 over 3. 0. Minus 4. 7. 22. Is that all? Who disagree with her? You also disagree with her? Hey, 031. 031. Oh yeah. 2 over 7. 1 over 8. 1 over 3. Is that all? Rational numbers. Who disagree with all of them? Who disagree with all of them? Okay, 012. Oh yeah. 9. 2. 1 over 8. 1 over 3. 0. Minus 4. 7. I say who disagree with them? Victoria. You agree with 019 now? I say who disagree with all of them? You agree with 019. We are picking one. I say who disagree with them? Any other disagreements? Now let's look at this. Answers. 020. Okay, enough here. Is are you sure? You better go school also. All right, now look at it here. Look at it here. Let's look at this question. This. It says what? Rational what? Numbers. It's 9 rational. Yes, because it can be expressed as 9 over 1. Yes. It's 2 rational. Yes, I agree with you. Is root 7 rational? Sword is an irrational number, so root 7 is not what? Rational. So we have what? 9 what? 2. Is pi rational? pi is rational, so it's not there. Is 22 over 7 rational? Yes, it's rational. 22 over what? 7. Is 1 over 8 rational? Yes, it's rational. 1 over 8. Is 1 over 3 rational? Yes, it's rational. 1 over 3. 0 unko? Yes. Minus 4 unko? 7 unko? So let's go. Who got it? 019 aka. 030, try and come here. And see what spoil show for 0.330. Root 7 is irrational. 022 only pick fractions. Only pick what is it called again? 1 over 1 over 3. I'm asking the whole numbers. Also were rational. 013 alpha. 013 bully rational, but do you now understand what a rational number is? Good. You now understand it now, right? Good. Look at this. Hello. Bless the choosing God here, man. We take it step by step. What do you choose? You raise your hand and answer it. All right. So 019 has entered the group of giants. 019. Now let's look at another one. Now, I keep numbers. Wait. Number says 3i, right? Number says 3i. 3 what? I. 4 plus 2 plus what? A bit. Okay. This thing. I'm coming now. Is this what you mean? Yes. Okay. 3i. 4. Sorry. 2. What's going on here? All my markers are not writing again. What's going on? So 2 plus 4i. 9. Root 7. Pi. 20 over 7. 1 over 8. 1 over 3. 0. Minus 4 and what? 7. All right. Now the next question is what? Irrational numbers. But I need some. I need a fresh bro that I've not tried before.
I'm not tried.
032 I've not tried before. 033. Our romantic is 032. All right, 032. Call. Root what? We're talking about what? Irrational number. So we have what? Root 7, and what? Pi. Who disagree with that? Nobody. So she has finally romantically entered this place. 022. That's good. Now let's go to the next one, number 9.
Continue.
Continuous rational numbers. Who have not done that? Okay, 022 I've not done before. 022 where? You may go you are laughing, you may go. Okay, next one. Are you ready? What's your let me try? 020. Aya. Call the continuous rational numbers here. Aya. Huh? Yeah, continuous rational. Aya. 20/7. Okay. Shh, 1 house, please. 1/3. Is that all? Call. 7. Okay. 9. Please, 1 house, please. See, 1 house, please. Okay, 9. Sorry. 9. 2. Is that all? -4. Who disagree with that? Do baby disagree with that? Come on, sir. Ever. Let me round up. No, let's give Duobi space. Yeah, she disagree with that. Hello, listen carefully. Hello, please. She said what? Wow. Are you serious? Yes. Now let's look at it says continuous what? Rational. Continuous what? So what it means is this. It's continuous. At the same time what? Rational. Now let's look at it. This is 3i, right? Yes. We have 9. Is 9 rational? Yeah? Is it continuous? Rule 7, uncle.
It's continuous.
Good. I like that. Please, any question you are trying to find out why other options are not the what answer. This is how to study. If you know there's no way the question will be so you cannot answer the question.
Continuous and irrational.
Good. 2/7.
Continuous and irrational.
So 2/7 is there. So 2/7 is what there, right? Now what of 1/8? Is what? Discrete. And what? Discrete and rational. So is it there? No. 1/3? Continuous and rational. So I will put 1/3. And what of 0? 0 is what? Rational and what? Discrete. -4, uncle. 7, uncle. So the answer is what? Wow. You be a center deal. Auntie Simu, go choose on go ya. So choose only ya. Now, hello. Whole numbers. And what are the whole numbers here? 9 what? 9, 12 what? 7. Is it true?
Yes.
From 1 up to positivity, right? Yes. Good. What of natural?
0, 7, 9.
0 from 0, right?
Yes.
Good. I agree with you. Prime. Integers.
Sorry?
Integers, uncle.
0. Apart from this thing. 0.
Yeah, is there. I think we stop here so you can come in. We'll continue from where? In our next class. We have overstayed our time, so he can teach you. So I think we stop here.
Yeah, we stop and we continue next time.
No, where did we stop? Where did we stop?
You stop at natural.
No. No, you know, we are entering people into this book.
Yes.
So where did she stop?
Continuous fractional number.
In the next class, we do a continue from where?
Whole number.
Okay, you have the number. 0 what?
22.
Write down this for me.
Sorry.
Are you doing this for anything? Yeah.
It's got to be where? All right, see you next class. No. It's not for CO. It's for other things. Let me sign, please. Sir. Okay. Sorry, what am I writing? 8. All right. Diego. Dá-lo.